Hello everyone, welcome to our first session. So we are going to cover in this session Maharashtra State Board 4th Standard English Medium Mathematics Part 1 and Chapter 1 is Geometrical Figures. So we'll just go through the syllabus. So what we are going to cover in our upcoming session. So in the part 1 we have 8 topics and in the part 2 we have same 8 topic. So first we'll try to cover part 1 and in the part 1 we have geometrical figures, number work, addition, subtraction, multiplication part 1, division part 1, coins and notes, then measuring time. So today we are going to see the geometrical figures. So let's see what we have in geometrical figures. So in the geometrical figures we have angles. So we have a number of angles here. So first one is see what they have given. We see angles between the grounds and the slides. So in the real time where we can see the angles. So generally if we see these slides, so see if we check the corner of these slides, so here we have one angle and here we have one angle. Also here also we have one angle. So these types of angles we have, but we don't know the see which angle we have. So we'll see in this chapter. So what is this angle we call in the mathematical language? So we have see here they have given three types of angle. First one is right angle, then acute angle, then obtuse angle. So first, we'll see right angles. So how we can define this is the right angle. So how we can say this is the right angle. Acute angle. An angle which is smaller than right angle is called as acute angle. Where where as we see earlier the right angle triangle which is nothing but the 90 degree. Okay. So now the angle which is less than 90 degree in mathematical words, see, the angle which is less than 90 degree is called as acute angle triangle. It means it is smaller than right angle triangle. Okay, we'll see some real time example. Here we have, okay, here watermelon. Now I have cut the watermelon into six slices. I have taken one slice, so now here we'll compare this slice with our protractor. Okay, here I have marked one line. Okay, and here similarly here I am marking one line. Now here see here this is the center of protractor and center of protractor is nothing but 90 degree. This is the base of protractor and here base of protractor starts from 0 degree. Okay. When the concept come angle, just remember what we have this protractor. So always remember this protractor and do not forget this center. This center is always 90 degree. It starts from 0 and ends with 180 degree. Okay, what next they have given? See, they have given some examples. Okay, acute angle. Okay, here they have given the clock. See, we can easily, understand the concept of these angles with the help of this clock. See, when you are see this three of the angle created between 3 o'clock and 12 o'clock is nothing but your right angle. And here now we'll take the same example. Now 3 o'clock and here 1 o'clock. Now the angle created between 1 o'clock and 3 o'clock is nothing but your right angle, your acute angle because this is less than your right angle. We see more real-time examples. See now here I'm taking our favorite dish. This is pizza. Okay. I'm just increasing the size. Okay. Now, if we cut pizza into the slice, okay, take one slice. See now this slice look like acute angle because this is less than 90 degree. This is less than right angle. That's why we call this is the acute angle. Acute angle is always smaller than your right angle. Now next is obtuse angle. So as we increase the distance between the tips of the plates, the angles between the plates grows bigger than the right angle. An angle that is bigger than right angle is called as obtuse angle. Now we saw the angle which is smaller than this right angle is the acute angle. Now angle which is greater than right angle is called as obtuse angle. So we can check on the protractor. Always remember the protractor. With the help of this you can easily remember the angle. Okay, now what they are saying, the angle which is greater than right angle is called as this obtuse angle. So now this is the baseline. Baseline always start from zero. Okay. Now this is if we consider this is the baseline and see this is the one of the line. Okay. So now always remember the center. So this is the center. Okay, if this is the center and if we check this line, see we can easily understand that this line is greater than 90 degree. So if this line is greater than this angle is greater than 90 degree, then we can say this is the obtuse angle. So we can check the real time example. We have some real time example. See, check this board. Okay. Okay, so this board, see, this is the baseline. Mark this as a baseline. Okay, this is the baseline. Okay, and if we mark this as a center, okay, now this corner, this end of this board, okay, see, look like, see, this one. Now, the corner of the board and the baseline, okay. So now the angle created between the corner of the board and the baseline is nothing but our obtuse angle. So this is the real-time example of obtuse angle. So just remember the board. Okay, just remember the corner of the board and the base of the board. Then the angle created between corner and the base is nothing but our obtuse angle. So we'll check few more example. Okay, we have this chair. Okay, we can see this chair on the beach. Okay, so just increasing. Now see here. So this is the base. Just draw the base. Okay. Now this is the baseline. Okay. This is the center. If we consider this is the center, so now center and this baseline means this is the right angle. But here now we have the corner also. So now the angle created between this corner, this side of this chair and the base of this chair is nothing but our obtuse angle because this is greater than right angle. So angle which is greater than right angle is nothing but obtuse angle, and the angle which is smaller than right angle is our acute angle. Okay, so these are the real-time example of acute angle, obtuse angle, and right angle. So always remember the protractor. See, this is the protractor. So center of the protractor is 90 degree. The protractor start from the zero and end with 180. So whenever the concept, the angle concept comes, just remember the protractor. So what next they have given? See, they have given some exercise. Okay, so observe the figure below and write right angle, acute angle, or obtuse angle in the box below each figure. Okay, so just we'll snip it. We have a snippet into here. We'll try to edit it. Okay, here. Okay, now see they have given the five figures, and out of this we have to identify which is the right angle, which is acute angle, and which is the obtuse angle. So here we can we'll do one thing. We'll go to the paint. Here, just take new paint. Here, paste it here. So now here we'll try to identify first one. The first one, see, just we'll consider this is the base, okay, this is the center. Now remember the protractor. If this is the center 90-degree, but here see they have given the figure like this. So this is, see we can see this is the smaller than 90-degree. Then so the angle which is smaller than right angle, it means what we can say, this is the our acute angle. This is acute angle. Okay. Now they have given one more figure. So here see we see a protractor like this. But if we rotate this protractor like this, see, we'll try to rotate this protractor. Now here I'm rotating the protractor. See, now I rotate the protractor. See, if you rotate, then also the center of the protractor is the 90-degree. Okay, it starts from 0 and end with 180. So similarly, in the figure we see they have given angle like this. So if we see, if we consider this is the baseline, okay, this is the baseline, okay, and this is the center line, okay, this is the baseline, and this is the center. Okay, so remember the protractor. The center of protractor is 90-degree, and this figure look like similar to the center of the protractor. This is the base, and this is the center. And what we can, if this is look like the center of the protractor, so this is nothing but our right angle. So what we can say, this is the right angle. This is right angle. This is the example of right angle. Okay, they have given one more figure. So here we'll just simply draw, this is the baseline. Okay, this is the baseline. Okay, if this is the baseline, and if we can say this is the center. Okay, this is the baseline and this is the center. Okay, the baseline starts from 0 and center means this is 90-degree. But here they have given figure like this, so which is greater than 90-degree. So what we have, the angle which is greater than 90-degree or angle which is greater than right angle is nothing but our obtuse angle. So this figure is nothing but the obtuse angle. Design. So similarly, see, they just rotate this figure like this. So this is the baseline. Okay, this is the baseline. Okay, Okay, this is the baseline. Okay, here we draw. This is the center. Okay, this is the center. But see, this line looks like greater than the center. So center is 90 degree, and if this angle is greater than 90 degree, then what we say? So this is nothing but our obtuse angle. So angle which is greater than right angle is nothing but our obtuse angle. So similarly, we have this one. So this is little bit confusing because see, if we check on the protractor, if this figure is not start from zero. Okay, so this not start from zero. So we'll just move this. Okay. See, I'm moving this. See, it is not this. This figure is not start from zero. So on the protractor, if we check, see something from here, this image, this figure is start, this angle is start. Okay, if the angle start from this, okay, and somewhere around this 60, this angle is ended. Okay, so if we consider this is the baseline and this is the see end line. Okay, this is the top line, this is the baseline. So but our center is okay. So if you check, so on the protractor the center is 90 degree. Okay, and now this angle also see which is smaller than 90 degree. Okay, on the protractor, see if I keep this image, this figure, then it looks like less than 90 degree, means it looks like smaller than our right angle. So the figure, the angle which is smaller than right angle, what we say? So we can say this as a our acute angle. So the angle which is smaller than right angle is nothing but acute angle. Okay. So here this is nothing but our obtuse angle. This is this nothing but active language. Okay, so we have done this exercise. So we'll check what next they have given. So they have given some dots and they ask us to join the dot. Okay, and when we join, so after they join, so they ask us to identify the okay, the angle created between these dots. Okay, make right angles by joining the dots in the box given below. They ask us to form the right angle. Okay, so to form the right angle, they ask us to join this dot. We'll take this on the paint. Okay, here I'm taking this. Now we'll come to the paint. Here I'm testing this. Now here they ask us to join these dots to form the right angle. So we try to join this dot here. See, and I'm trying to join this dot. See this one. So this is the center. So this is the center. Okay. So here, okay, this is the center, and this is the base. Okay. So center is nothing but say 90 degree. So if the center is 90 degree and base is zero or base okay base is zero, then what we say? We say this is the right angle. So similarly we can draw from here. So this is the center. Okay, this is the center. Okay, and this is the baseline. Okay, If this is the center and this is the baseline, then what we say this is the right angle. So similarly, what we have next, same they ask us to join the dot to form the acute angle. So here we'll just take this to form the right this acute angle. Here I'm taking this. This is the baseline and this is the top line. Okay, so now see the angle which is smaller than right angle is nothing but acute angle. See this if we consider this as the center, so center of protractor is 90 degree and see this line is less than 90 degree. So that's why we say this is the acute angle. So similarly I'm drawing line here, then here I'm joining this dot. So this is nothing but acute angle. Similarly, here I'm taking what we can take. So this one, this is the baseline. Okay, and now I'm joining this row. Okay, so this is nothing but acute angle. Now, similarly, what they have given next, so they have given see make obtuse angle by joining the dots. Okay, we'll just snip it. Okay, so here, so we'll draw first the baseline. So this is the if this is the baseline. Now they ask us to form obtuse angle. So obtuse angle, if this is the center, so now we have to draw the angle which is greater than the center, means which is greater than the right angle. So here, if we want to draw the greater than, so we have to join these dots. I think here we have to increase the line. This one. Okay. So this is the example of obtuse angle. So here one more how we can draw. So we will try to draw from top. Okay. So this is the baseline. Okay. Now from here to here, here to here. Okay. So this is the example of obtuse angle. So what they have given next there. Acute angle and obtuse angle at your elbow. Show these angles to your friends and check there. So we have to move our elbow like to form the acute angle, right angle, and obtuse angle, and we have to show it to our friend. So you can try at your home. So what next they have given? Check is this true? Okay, they have given some statement, and we have to identify if it is true or false. Now, angle and electric pole makes with the ground is a right angle. So similarly, as we have seen the example of tree, so we can compare this electric pole with tree, and we'll try to identify if it is. See, if we consider this as the pole, and this is the ground. So now they ask to angle created between the ground and this pole. So this is nothing but our right angle triangle. Now what they ask, the angle an electric pole makes with the ground is the right angle. So this is the true, because see this example. So this is the pole and this is the ground. Now angle created between pole and ground is nothing but right angle triangle. Right angle. Now the slides makes one acute angle and one obtuse angle with the ground. So next one is the slides makes one acute angle and one obtuse angles with the ground. So we'll take the slides example. Here see we have slide. Here we don't have. So we'll take the example from the book. Okay, so this is the slides. We will try to snip it. What they have asked. So they have asked, what is the question? How the angle the slide makes one acute angle and one obtuse angle with the ground. So, so they ask acute angle and obtuse angle. See this one. So if you check this one, so this is the slides. See here, if we check this, so here, see this is the base and this is the top. So top is less than right angle. So this is nothing but acute angle. Now this is the base and this is the top. So this is greater than our right angle. So this is nothing but our obtuse angle. So it means, so the statement given is the true statement. Now the ladder makes one acute angle and one obtuse angle with the wall. So we'll take the ladder here. Consider. See, this is the ladder. So here, if we check this one, so what they ask two angle, but here we can see only one angle, which is the acute angle. Okay, so ladder is creating only one angle, which is nothing but acute angle. Why it is acute angle? Because it is smaller than right angle. It is smaller than 90 degree. That's why we can say this as a acute angle. So here it means, see, this third statement is false. The ladder makes only one angle, which is acute angle. The angles between thorns of the babul tree is an obtuse angle. Now they ask us to find out angles between the thorns of babul tree. So we'll come to the tree. Okay, so here, see, this is one angle, this one angle, this is one angle, this is one angle. So what we can see here, see, all angles looks like a smaller than the right angle. So it means this is the acute angle, and what they have given here, the angle between thorns of the babul tree is the obtuse angle. No, it is not obtuse angle, and it is not greater than the right angle. It is smaller than right angle. That's why this is the acute angle. It means this statement is false. Now, leaving the thumb, the angles between any two adjoint fingers is a acute angle. Okay, so leaving the thumbs, it means we have to take our hand. Okay, okay, if we see our hand, okay, so leaving the thumbs, leave your thumb. Now check the angle between your two fingers. So what we can see, So we can see angle is smaller than the right angle. So it means this is the acute angle. So it means the given statement is true. So the angles between any two adjoint figures is an acute angle. So this statement is correct. So what they have given next? So they have given circle. So we can see circles. So where we can see the circles in real time. So bangle. They have given bicycle wheels. They have given cart wheels. So if we see the pizza, the whole pizza looks like a wheel. If we cut the pizza, then it will create the acute angle. The slice, the angle of slices looks like acute angle. So here, so now we are going to see the circle. What they have given in the circle. See, they ask us to take a small steel bowl, place it upside down on the piece of paper, and trace its outline. Remove the bowls. The figure you get on the piece of paper is the circle. Now we'll draw one. Okay, we'll draw one circle. Okay, so now this is the circle. First, we have to identify center of the circle so that we can understand the concept. So this is the, if we consider this as the center, so what they have given next here, see, draw two or three circles like this one and cut out a circle paper. So now we have not drawn this on the paper. So we have to just understand the concept using the our drawing. Okay, take one of these shapes and fold it as a drawing paper. Okay, so we'll try to understand chord on the this drawing. Okay, come to the drawings. So see, now we consider this. Okay, this part here. Now it is joining the point A and point B on the circle. Okay, we'll just give the name. Okay, this is the point A. This is point A, and this is point B on the circle. Okay, now see, it join the point on the circle. Okay, but not passing from the center. Okay, so this is the center. Now we join these 2 points, not from the center. Okay, now suppose, what we can say, so this, the line which is not passing from the circle, passing from the center of the circle, but it is joining the 2 point on the circle. So this line is nothing but a chord. We can say this as a chord. Why? See, this 1 point, this is not passing from the center of the circle, but next point, but these join the 2 points on the circle. Okay, so the concept is, see, the line which is not passing from the center, but it joins the 2 point on the circle. Point A, we here we have joined the 2 point A and B. So here, what we can say, this line, so this is nothing but the chord of the circle. Okay, here we understood the chord. So what next they have given? Now they have given diameter. So how we can understand diameter? Now here, see, consider the center point first. Now here, take 2 points on the circle. Here point P. Okay, here point Q. Now I'm trying to join these 2 points, but this time it is passing from the center. Okay, now this line passing from the center. Okay, so Here earlier we join these 2 points, but which was not passing from the center. But this time we join 2 points, but it is passing from the center. So the line, see, we connected 2 points, but it is passing from the center. Okay, if it is passing from the center, then this line consider as the diameter of the circle. So if you fold if we consider this on the paper, and if we fold this part such as, see, this can be considered as the center, and fold the paper piece of the paper, then the center consider as the diameter of the circle. So in the simple way, see, we connected the 2 points on the circle, which is passing from the center point of the circle. So the line created between these two points is nothing but the diameter of the circle. I hope you guys understood this concept. So what next they have given? They have given, see, they have given radius. Already we draw the center point. Okay, so center point is nothing but the, see, uh, if we divide the circle into four similar parts, so where the okay, these two lines are joined between. Okay, so this is nothing but the center of the circle. See how we can understood on this. We will just take, okay, now this is the circle. Now we are trying to divide the circle into four similar parts. Okay, here this is the, I draw first line. Here now I have divided this circle into two same parts. Now I want to divide it from this line. Okay, now we can see, now we can see circle is divided into four similar parts. So where these two lines are joined, okay, where the two lines are meet, so their meeting point is nothing but our center of the circle. So this is the center of the circle. So now what they have given next? They have given the radius. Name the center of the circle M. Take any point P on the circle. Draw the line MP with your ruler. MP is the radius of the circle. Okay. So come to the our drawing. Okay, we identified the center. So this is the center. Okay, this is the center. Now what they ask. So just give the name to the center point. So this is the point M. Okay. If this is the point M. Okay, now take one more point on the circle. Okay, it's the border of the circle. Take one point on the border of the circle. So here, this is the A, point A. Now, what we do? So just from the center to, just draw a line from center to the this point. Okay, so this line is nothing but the radius of the circle. So line MA is the radius of the circle. Now see, simple concept. So line which is not passing from the center but start from the center and joining one of the point on the circle. So this line is nothing but the radius of the circle. So I hope you understand this radius. So here they are asking to draw circle with the help of the compass. See these tools. So if you have the compass box, so you can see this in your compass box. So with the help of this, they ask us to draw the circle. So just one side of this tool, we have to attach the pencil, and one side we have to put on the circle, and we have to draw the circle. So using this we can draw the circle. Now they have given one exercise. Look at each circle. Is the line shown by the arrow a chord, a diameter, or a radius of the circle? Right in the box game. They ask, see, they just draw a line and they ask us to identify the concept as earlier we have seen. So just we'll snip it and we'll try to understand what they have given. Okay, here, see they just given the point. See the point is nothing but what they have given. This is the center, because this is the center. See, if we divide the circle into four similar parts, then the meeting point of this lines is nothing but the center point. So this they have already given, this is the center. Now see this line. So are what we seen in the example. See the line which is not passing from the center point, but it's join the 2 points on the circle, which what we call. So this is the chord. This is the chord of the circle. Why this is the chord? Because see, this is not simple. This is not passing from the center. Okay, but it is join. What is join? It join the 2 point on the circle. So that's why we say this is a chord. So this is nothing but the chord. So what next they have given? See, now here this time line which is passing from the center point of the circle, and if it join the 2 point on the circle, so what we say this line. So this line is nothing but the diameter. Okay, diameter of the circle. Why it is diameter? Because it is passing from the center point of the circle and joining the 2 points on the circle. So this is nothing but diameter of the circle. This is the diameter. Next, so line which is start from the center point of the circle, and it's join the one of the point on the circle. Okay, here if we give the name A, and if the center point is M, so the line M and A is the radius of the circle. Why we can say it is the radius? Because it start from the circle and it is join the 1 point on the circle, is nothing but the radius of the circle. I hope you understood. So here we have clear the four concept of the circle: center, chord, diameter, and the radius. So what next they have given? So next they have given vertex and sides. Observe the figure and complete the table below. So here name of the figure. So we'll first see the concept. Okay, what we can say this is, what we can say this, what we can say this. So now they have given first rectangle. So first we'll just clear this concept, then we can understand this one. Okay, rectangle. So why we say this as a rectangle? Okay, a rectangle has four edges, that is, four sides. The point where two sides meet is called as a vertex. In the figure alongside, A, B, C, D are the vertices. Okay, these are the vertices. And here, first we'll understand why we say this as a rectangle. Okay, we'll check on the paint. Okay, why we say this as a rectangle? So here I draw one. See, in this figure, okay, why this is the rectangle? In the rectangle, okay, here in the rectangle, see this, these two, the line, so which is in front of each other. Okay, the line which is in front of each other. See now, so this is the A, this is the B, and this is point C, and this is point D. Now we have the line AB and line DC in front of each other. So in this rectangle, line which are in front of each other are parallel to each other. Okay, so AB is in front of DC. So if AB is parallel to DC, okay, and AD is parallel to BC, it means, so we can say, if we see these conditions, then we can say this figure as a rectangle, because in the rectangle, line which are the in front of each other are parallel to each other. But similarly, we have one more figure. Okay, we have one more concept here. Okay, here now this time we draw image where all lines are parallel to each other. So in this case, we say this is the square. Okay, in this square, all lines are parallel to each other. So this, we can say this square. In this square, all lines are parallel to each other. So this is parallel to this one parallel to this. It means in the square all lines are parallel to each other, but in the rectangle only in front of each other. Okay, the line which is in front of each other are parallel to each other. Okay, so AD is parallel to BC and AB is parallel to DC. So what we saw rectangle, we saw square. Now triangle. Okay. So first we'll clear this concept. Okay, rectangle. So from the rectangle, what they ask us to, okay, find out the vertex. Okay. So now what we can say the vertex. Okay. So the line, the meeting point of two lines is nothing but the vertex. Okay. So this A is the meeting point of AD and AB. Okay. Similarly, B is the meeting point of AB and BC. Similarly, C is the meeting point of BC and DC. Okay. Similarly, D is the meeting point of AD and DC. So the point where two lines are meet each other is nothing but your vertex. So this is the vertex where two lines are meet each other. So here, so we saw the vertex. Okay, from this figure we can easily understand the, see, we can give this name. Okay, name of the figure. See, if we see this figure, see here, see two in front of lines are parallel to each other. See, this line is in front of these lines and both are parallel to each other. So this is nothing but what we say this example, this is the rectangle, and here see in this image, see all the lines are parallel to each other. See here we have four lines and four lines parallel to four sides parallel to each other. This is nothing but the square. See number of sides here 4, here also number of sides 4. Number of corners, corner is nothing but, see corner is nothing but the vertex. Okay, so here how many corners we have? We have 4 corners. Okay, here see here they have given the concept. See what earlier we seen, the opposite sides of the rectangles are equal length. All the angles of a rectangles are right angle. A rectangle is called as a right angle quadrilateral. Okay, see opposite sides are parallel to each other. Okay, so this is nothing but the rectangle, and in the squares all the sides of the squares are equal length. See what we seen in this example. See here, see all sides are equal to each other. Okay, this is nothing but a square. Now come to the triangle. So okay, a triangle has three vertices and three sides. Y, R, and L are the vertices of this triangle. Okay, a triangle has three angles. So here, as we see in the rectangle and square, we have four angles. Okay, but the angle where we have, see in this figure we have only three angles. That's why we say this is the triangle. Okay, we'll take example here. Yeah, see here I'm drawing this figure. Okay, here We have only three angles. That's why this is the triangle. And here in the triangle we have only three sides. Okay. So why we say this is the triangle? Because this figure has only three angles. That's why we say this is the triangle. And in the triangle we have only three sides. That's why we say this is nothing but a triangle. Okay. I will give the name A, B, and C. Okay, and what we say this is A. What we say this A. So this is the vertex. Why this is vertex? Because here in this point two lines meet each other. That's why we say this as the vertex. Okay, I think we have clear the all three concept here: rectangle, square, triangle, and vertex. Okay. So here they have given one exercise. Look at the figure and complete the tables below. We will take on this knitting tools. Okay, just cut this image. Okay, here what they have given. Look at the figure and complete the table below. Now what they ask, name of the side. Here they have given the example. Here they have given side AB. So side AB is this one. What we have next? We have BC, we have AC. So here we have to write. Okay, they have given AB. Now BC. Okay, we have BC and we have AC. Okay, so next they have given. See what we can see in the next figure. See, these PQ opposite sides are parallel to each other. It means this figure is what we can say this figure is rectangle. And now they have to we have to identify the sides. They have given PQ. So what next we have after PQ? What we have? So we have QR. We have QR. What next we have? We have RS or SR. Then what we have SP or PS. Yeah, SP. Okay. So here these three sides we have. Okay. Now what they have given. So here see all sides are parallel to each other. So when all sides are parallel to each other, what we can say this is the square. Okay. Here they have given side LM. So next side is MN and then NO, then OL. Okay, these are the sides. Okay, next what they ask, name the vertices. So vertices means the meeting point of two lines. So where the two lines are meet each other, it is nothing but your vertices. Okay, here they have given the A. So next one is B. Okay, and remaining one is C. Okay, here now here they have given example P. See here the two lines meet each other. Here we have the Q where two lines meet each other. Then we have R. Then we have S. So next on the next they have given L. Then next vertex is M. Then N. Then O. Okay. So here we have completed this exercise. So what they have given next. Okay. Now we have completed all the topics from this first chapter. So what we have clear in this chapter. So we'll summarize. We'll just revise it once. Okay, so that we can easily remember what we have seen first. We have seen right angle. So we are going to now summarize what we have seen in this first chapter, geometrical figure. So in the geometrical figure, first we saw right angle, second we saw acute angle. Next we saw obtuse angle. So why we say right angle? So when we say right angle, when the baseline, the angle created between baseline and the center of the protractor is nothing but right angle. So we have seen the example of right angle is okay, angle created between corner of your window, then angle created between tree and ground, then angle created between electricity pole and ground. Okay, so these are the example we have seen in the right angle. So acute angle means the angle which is smaller than right angle is nothing but acute angle. The we have seen the real time example slice of watermelon. Okay, slice of watermelon we have seen. Then we have seen slice of the pizza. So these are the example of acute angle. So then next what we have seen obtuse angle. Okay, the angle which is greater than right angle is the example of this is nothing but obtuse angle. So real time example of what we have seen the boat. Okay, the base of the boat and corner of the boat, the angle created between corner and the base is nothing but the obtuse angle. Then what we have seen in this, we have seen chair on the beach. So the corner and the base, the angle created between this is nothing but obtuse angle. So what we see next, fourth one, we seen circle. Okay, in the circle what we seen, center, center of the circle, center of the circle. Okay, then next fifth one we have seen the chord. Then next we have seen diameter. Next in the circle we have seen radius. Okay, center, it means if we divide circle into four similar part and the meeting point of this, okay, two lines, okay, center, what we say, the meeting point, this is nothing but the center of the circle. Chord. Chord means the line which is not passing from the center point of the circle, but it is joining two point on the circle is nothing but that line is nothing but chord of the circle. Now the diameter, diameter nothing but okay, the line which is passing from the center point of the circle and joining the two point on the circle is nothing but diameter. Now radius, radius means the line which is start from the center point of the circle and joining one of the point on the circle is nothing but the radius of the circle. Next, what we have seen rectangle, rectangle, then square, square, then we have seen the triangle, and in this we have seen vertex. Okay, so these are topic we have covered. So rectangle, when we can say this is the rectangle, because in the rectangle opposite sides are parallel to each other and rectangle has four sides. Okay, and the meeting point of two sides is nothing but the vertex. Okay, and square, square, when we say it is the square, the squares we have four sides and four sides are parallel to each other. Okay, four sides are equal, but in the rectangle only opposite sides are equal. Rectangles also has the four sides and square also has the four sides. In the triangle, okay, we have only three angles. Okay, three angles and three sides. This is nothing but the triangle. Okay, and vertex where the two sides are meeting each other, the meeting this meeting point is nothing but our what text? Okay, so this is here we are wrapping our class. Okay, so thanks for your time. Thanks for the your okay the patience. Okay, so I hope you have understood what we have learned earlier. Okay, so if you have any doubt, so I'm giving the link of the Telegram channel. Okay, so in that Telegram group, you can simply ask your questions if you have doubt related to this first chapter. Okay, thanks all, and have a good day.